Hello everyone, welcome to the dynamic world with Suraj. Today our topic is convection current from geography. Let us go through the introduction first. So what is convection current? Let us know about this. Convection current is the process where heat is transferred from underlying layers to the overlying layers due to temperature and pressure differentiation. The advection and diffusion process also takes place during convection. Convection mainly takes place within gas and fluids or molten materials when bulk intermolecular movement takes place in solid materials. The convection can't take place because neither diffusion nor advection occurs in solid materials and no flow of current is observed here. During convection, at the very beginning, the underlying strata get heated first. A temperature gradient is formed between the lower and upper layer of that substance. The upper layer is relatively cooler than the lower layer. At that particular time when diffusion starts within the molecules of that substance, now the heat is transferred due to bulk movement of the molecules of that substance. A current is created during this movement which is known as convection current. So all of you, let us go through this picture. Here the movement of convection current is shown. First of all, the movement starts from the bottom and it starts moving towards the upper area. Okay, so convection always take place from bottom most of the cases, and it again rise and it again descends downward. Why? Because when heat is transferred from lower layer towards the upper layer now get heated, so the cold water, fluid or gaseous substance now descend downward and it again get heated and again it rise upward and again it get heated at the overlying layers and it again descends downward. So this is a continuous process and the convection takes place throughout the whole process of heating. Now let us go through the next part, some example of convection. So convection, we know that the heat which is generated in the earth's interior is also a type of convection. Okay, so that heat is produced by some radiogenic decay. So let us discuss about that current. So in upper mantle layer is composed of molten viscous rocks which are semi-elastic in nature. So when the heat is generated by radioactive decay of materials like potassium, thorium and uranium present in the core and mantle of this earth, it leads to the heating of semi-elastic layer of mantle from bottom towards the top where the heat is extended within lower layer and upper layer. The hot liquid molecules from bottom ascends upward whereas relatively less hotter molecules of upper layer descends and here convection current is created. This convection current leads to the formation of convection shell which pushes the crustal and oceanic plates away from each other in some place and towards each other in another point. This current is mainly responsible for the formation of different landform features on the Earth's surface. It creates cracks and fractures, folding and faulting, and so on, during which magma also rises upward and reaches the surface, which is the major substance of convection inside the Earth. So, this is the picture of Earth's interior where the heat is actually generated in the core as well as in the mantle, and that heat actually transferred towards the crustal plates, and the continuous movement of this heat actually takes place here in the asthenospheric layer as well as the semi-elastic layer of upper mantle. So this is the process of convection and this current is known as convection current. Now let us go through the next examples. So convection of air. Air is also convected during the heating of the surface during daytime. So let us continue about that topic. Convection of air occurs when the heating of air surface or air from surface takes place due to radiation of heat from Earth's surface. The Earth's surface heated very rapidly during daytime due to solar radiation and it re-radiates the heat back to the atmosphere by terrestrial radiation. In this process, the air layer above Earth's surface absorbs the heat and it tries to blow upward to get cooler. The hot air expand and rise upward. They become cooler due to lapse rate and certain height. It become cold, dense and heavy when it again descends downwards towards the surface when convection current is created. Due to exchange of heat from lower layer to the upper layer, the whole process of convection takes place in a circular manner. So we can see here the air is ascending, the cool air, warm air, they actually ascending here. It become warm due to terrestrial heating and rising upward. Okay, when it rise upward, it again go to the tropospheric layer and it actually become cold. It become dense and compacted. Then this heavy air again descend downward. It actually sink and it also reaches to the surface, and after reaching to the surface it again get heated by the terrestrial radiation and again it actually ascend upwards. So this whole phenomena actually occur continuously throughout the day or year. Now let us continue to the next example, that is convection of water. So water is also convected from below when it get heated by any medium. So let us continue with this point. So when water is heated from below, the warm water becomes lighter than the cold water above it. At this time, the warm water ascends upwards and the cold water sinks to the bottom. So the energy is transferred from lower layer to the upper layer. This whole process takes place in a circular motion and known as convection of water. So all of you can see that in this example, in this diagram, the heating is actually done in the bottom and the water is actually lifted upward. It is actually ascending upward and it mixing with the cold water at the overlying layers. Okay, and this cold water again descending. Okay, and after descending downward it again become hot. It actually getting heated and it again actually ascending upward. So all of you, I hope the topic of convection current is clear to all of you. So keep watching my channel and we'll meet again in our next session. So thank you all of you for watching the video. Bye everybody.